Once again, welcome to chemistry classes by Vijay Kumar Sethi, class 12th chemistry, aldehydes, ketones and carboxylic acid, and we will start chemical reactions of aldehydes and ketones, and in this video we will discuss about nucleophilic addition reactions of aldehydes and ketones. Aldehydes and ketones undergo nucleophilic addition reaction. Actually, these are the characteristic reaction of aldehydes and ketones, nucleophilic addition reaction. In the 11th standard, we have discussed that alkenes undergo electrophilic addition reaction. Okay. Now, what is the mechanism of this nucleophilic addition reaction? We already discussed the structure of this carbonyl group. In carbonyl group, this oxygen acquired the partial negative charge and carbon acquired the partial positive charge. That's why this nucleophile can attack to this carbon. Okay, a nucleophile attacks the electrophilic carbon atom of the polar carbonyl group. The hybridization of carbon changes from sp2 to sp3 and a tetrahedral alkoxide intermediate is produced. This carbon is sp2 hybridized. Okay, and when a nucleophile attacks on this will convert into this tetrahedral intermediate, and this carbon becomes sp3 hybrid. Okay, now this intermediate captures a proton to give the electrically neutral product. This is tetrahedral intermediate, this take this H plus, and finally this will convert into addition product. If you see the net result, that is from this to this, what change is taking place? The net result is addition of nucleophile and H plus across the carbon oxygen double bond. Okay. Now, reactivity of aldehydes and ketones towards nucleophilic addition reactions. Aldehydes are generally more reactive than ketones in nucleophilic addition reactions due to steric and electronic reasons. Sterically, the presence of two alkyl groups in ketones hinders the approach of nucleophile to carbonyl carbon than in aldehydes which have only one alkyl group. As we know, that is, aldehyde can be represented like this. Okay, this R may also H, and in case of ketone, this carbonyl carbon is attached with the two alkyl groups. Okay, that's why this carbon is sterically hindered compared to this carbon of aldehyde. Now, electronically, in ketones, two alkyl groups. Now, again, as we know, alkyl groups have plus I effect, that is electron releasing effect. That's why these two alkyl groups reduce the electrophilicity, that is positive charge of the carbonyl carbon more effectively than in aldehyde. Okay, because of these two reasons, aldehydes are more reactive than ketones. Now again, if you are asked which one is more reactive, methanol or ethanol, that is HCHO and CS3CHO. Now, if we consider these two effects, then we can say this methanol is more reactive compared to this ethanol. Okay. So there is one question, problem 12.3. Would you expect benzaldehyde to be more reactive or less reactive in nucleophilic addition reactions than propanol? Explain your answer. Now we are going to compare aromatic aldehyde and aliphatic aldehyde. Answer is the carbon atom of the carbonyl group of benzaldehyde is less electrophilic than carbon atom of the carbonyl group present in propanol. The polarity of carbonyl group is reduced in benzaldehyde due to resonance, hence it is less reactive than propanol. Benzaldehyde is less reactive than propanol because of the resonance. Okay, the polarity of carbonyl group is reduced. This, and these are the resonating structures shown for this benzaldehyde. Okay. Now, addition of hydrogen cyanide (HCN). Aldehydes and ketones react with hydrogen cyanide to yield cyanohydrins. This is HCN in the presence of OH minus ion. This will give nucleophile CN minus. And this nucleophile attack to this carbonyl carbon, and we will get this tetrahedral intermediate. And then this will capture this H plus sign and convert into cyanohydrin. We can represent this reaction like this is propanone. When this is treated with the HCN, now again see what overall change is taking place. This H will add to this oxygen, and this CN will add to this carbon, and this carbon oxygen, this double bond will broken down. Okay, and we will get this result. Actually, the cyanohydrins are the important organic compounds because these are used to prepare number of other organic compounds. Actually, this CN group may be converted into the amines on reduction. That is, this CN group may be converted into CH2NH2. That is primary amine. If this is partially hydrolyzed, then this will convert into the amide CONH2. And if this group is completely hydrolyzed, this will convert into COOH. Okay, that's why we can get the number of compounds from this cyanohydrin. Now, addition of sodium hydrogen sulphite, that is NaHSO3, sodium hydrogen sulphite. Okay, now this is carbonyl group of aldehyde and ketone. Now, in this case, again you can observe actually this NaHCO3. In this case, this OSO2H group is added to this carbon, and ONA, that is this Na of this will add to this oxygen, and in this case proton transfer is taking place, and this Na will shift to this and H will shift to this, and we will get bisulfite addition compound, and which can be obtained as a precipitate. This is a crystalline compound. The hydrogen sulfide addition compound is water soluble and can be converted back to the original carbonyl compound by treating it with dilute mineral acid or alkali. Therefore, these are useful for separation and purification of aldehydes. Again, you can see the reaction. This is ethanol. When react with NaHCO3, we will get this bisulfite addition compound, and on hydrolysis, this will again regenerate the pure carbonyl compound, that is pure aldehyde. Okay. Addition of Grignard reagent. Carbonyl compounds are converted into alcohols. If you remember, this reaction we already discussed in the preparation of alcohols. Okay, from carbonyl compound and reaction of Grignard reagent. This is carbonyl compound and this is the Grignard reagent. Now in this case, this R will add to this carbonyl carbon, and this MgX part will add to this oxygen, and will get the first adduct. Addition compound is formed, and on hydrolysis of this, okay, we can say this will break from this position, and H will go to this and OH will go to this, and we will get this alcohol. Now methanol will give primary alcohol, other aldehydes will give secondary alcohol, and ketones will give tertiary alcohol. Like this is HCHO. When react with RMGX, this is one addition compound is formed, and on hydrolysis this will give primary alcohol. This is aldehyde other than methanol. Okay, and this will result in this secondary alcohol. And this is ketone. This result in the formation of tertiary alcohol. Okay. Addition of alcohols. Aldehydes react with one equivalent of monohydric alcohol in the presence of dry hydrogen chloride to yield alkoxy alcohol intermediate, which is known as hemiacetals, which further react with one more molecule of alcohol to give a JAM dialkoxy. JAM means it is on the same carbon atom two alkoxy groups are attached. That is JAM dialkoxy compound known as acetyl. See, this is RCHO. When this is react with the alcohol in the presence of HCl gas, we'll get this hemiacetal. Okay. This H of this alcohol will add to the oxygen of carbonyl, that is a carbonyl group, and this is alkoxy group will add to the carbonyl carbon. This may further react with the another molecule of alcohol and you will get this acetyl, and this is the JAM dialkoxy. Actually, this OR dash is alkoxy group, this is OR dash is also alkoxy groups, and both groups are attached to the same carbon atom. Okay. Ketones react with ethylene glycol in the presence of dry hydrogen chloride to form cyclic products known as ethylene glycol ketanes. See, this is ketone and this is ethylene glycol, CH2OH, CH2OH. Okay, in the presence of HCl gas, this will form ethylene glycol ketone, and its reverse is also possible. If this is, that is, ethylene glycol ketone is reacted with the dilute HCl, again we will get this ketone. Okay. Acetyls and ketanes are hydrolyzed with aqueous mineral acids to yield corresponding aldehydes and ketones respectively. That is, acetyls may be converted into aldehyde and ketanes will be converted into ketones. Okay, thank you.